I'm Jason Dover, Vice President of Product Strategy here at Kemp Technologies, and I'm joined today with Kurt Young, our Senior Product Strategy Manager. How's it going today, Kurt?
Real good, Jason. You?
Pretty good, pretty good. So we're getting together today to chat about some of our new capabilities in our ECS Connection Manager. Of course, our ECS Connection Manager is a purpose-built load balancer and application proxy for Dell EMC ECS object storage. And just recently, we've brought out some new capabilities that are exciting and that provide QoS functionality that's specifically catered for ECS. Kurt, you want to just give a brief overview of what this feature set is actually all about?
Yeah, absolutely. Yeah, so we've introduced, as you said, some new controls and visibility, providing quality of service or rate limiting of traffic traversing the load balancer. Right? So this allows administrators the ability to provide fair and balanced access to ECS nodes running behind ECS Connection Manager.
Sounds great. So an immediate question that comes up is why does object storage like ECS actually require QoS and rate limiting functionality in the first place? I mean, normally when you think of those type of capabilities, you think of them in the construct of networking, right? You know, perhaps being able to set flags on packets and hope that the next switch or router respects those from a prioritization perspective. But when you think about this from a storage point of view, why is it that object storage would also require similar types of functionality?
Yeah, it's a great question. And more times than not, ECS is deployed in this kind of shared environment, whether it be multi-tenancy or different business units having one or more applications accessing or requiring access to the object storage solution. With that, you're quickly going to lose some controls over resource contention on ECS and have to address it. Have it be rogue applications, noisy neighbors, bad actors. These are all no good and will have a negative impact on all the applications unless there's some kind of throttling that will protect the shared storage. In some cases, you also have applications that require near real-time responsiveness to the storage. Where any kind of latency or lack of available resources could be detrimental, right, to the success of the application. Talking about things like smart cities and IoT and all of these different next generation applications where this kind of responsiveness is required. And you have some solutions that could use some throttling due to its nature. An archival system using ECS as like tier 2 storage, where if it took several minutes to execute a write to the storage due to the throttling, that would be more than acceptable.
Okay, that makes a lot of sense. So there's kind of two factors there. There's the prioritization piece, right, of being able to give workloads or applications that are more important their fair share, while maybe reducing the access that lower priority apps or workloads you mentioned archiving. But then there's also the protection mechanisms as well to prevent errant applications or bad actors. It's interesting you mentioned that concept of smart cities as well. We know that that's a primary use case for EMC ECS. And just think of that, a smart city, maybe you've got IoT devices and sensors. Imagine that they were hijacked and converted into a botnet. Well, if you didn't have any type of throttling capabilities there, that could lead to the storage being overwhelmed with whatever processing they're doing and get in the way of things that are actually really important. Could be analytics that's making real-time decisions for things that are going on inside of that smart city and the services that people are actually relying on. So that really drives home the point of just how important QoS is when it comes to object storage and specifically for ECS. So next question then, how does this feature actually work? We touched on it a little bit, obviously, in being able to control the amount of traffic that's going through the ECS Connection Manager to both protect as well as prioritize. But let's dig into the next level of detail. What are the options that are available to an administrator to manipulate and control policy when it comes to QoS around ECS?
Yeah, Jason. So there's actually several levels of control. Starting at a global level, ECS Connection Manager can limit total concurrent client connections or client connections per second, we consider CPS, or HTTP requests per second, RPS. Doing this at a global level will ensure that no single system can take more than their share of system resources of the ECS solution. If
Got it. Can you go down more granular than that as well?
Yeah. If we move down one level, Connection Manager can also identify traffic based on network or source IP address of the applications accessing the storage. This allows for that prioritization of traffic, giving application A more connections per second or requests per second than application Z. And then again, this goes back to that near real-time responsiveness.
What about at a bucket level? We know that the construct for looking at different parts of the ECS infrastructure often comes down to buckets. Are you able to identify and understand buckets and be able to make control based on that as well?
Yeah, and what we're using actually regular expressions, so we can actually look at it from a bucket instance or even a namespace instance as it pertains to ECS, identifying that kind of traffic and throttling based on that match. And by using regex, right, this allows us to support both the path style addressing and the virtual hosted addressing methods.
So since we're using regular expressions, certainly there's quite a lot of flexibility in terms of what can be looked at to influence the policy, looking at things such as user agent and elsewise. You have basically total flexibility since you're using regular expressions. Are there any other capabilities associated with this feature that come into play for common ECS deployments?
Yeah, I mean, another key feature is how we're throttling this traffic, right? One could just drop the packets and let the application deal with resending the packet until it goes through. We took the extra step to allow response codes like a 429, too many requests, or a 503, service unavailable, to gracefully throttle the connections, allowing the application to adjust based on the policies. Furthermore, we're providing the administrators visibility of the top 10 systems that are accessing the storage, and the top talkers, based on the allowed connections and the block connections for each. Right. This gives the administrators the ability to address these the application's behaviors, those bad actors, or use it to increase the limit for certain applications that are requiring more resources.
Those two things are certainly important. One, doing it gracefully so you don't break the application, and then also having visibility, having some level of analytics to understand what's going on. As you mentioned, if there's a bad actor that's creating some sort of issues, hogging resources, being able to quickly identify that is certainly important. And also identifying legitimate use cases where certain applications perhaps should be given a bit more leeway because their usage has expanded. It certainly sounds like a really important feature and one that will come in handy for ECS deployments. Is there any other capabilities that are being planned on expanding around this feature as well?
Yeah, in addition to the connections per second and the requests per second, we're adding the ability to apply QoS on bandwidth. And we'll be able to give customers, many choices that will cover nearly any use case as it pertains to applying the QoS and rate limiting in their environment.
Okay, that sounds good. Kurt, it's been great having this brief chat. Look forward to doing another session where maybe we'll deep dive a little bit more into this feature set with some demonstrations as well.
Yeah, looking forward to it, Jason.
All right, have a good one.
You too.